What we've done so far in the last video is just introduced you to chi-squared and some of the terminology and formulas. Now in this video we're going to go out and calculate the expected values that a sample should have and the chi-squared value. Again, don't worry too much about all the 7 steps. We'll get that in the videos farther along. So here's our example. We go out and watch 60 people and we ask them this question. Are people over the age of 21 more likely to pass their driver's test the first time? So we start asking people questions and we say, if you're over 21, did you pass the test the first time? Did you fail it? And if you are under 21, did you pass it or fail it? And so we are gathering information for 60 people. And what we did is we took 40 people that are over 21 and 20 people that are under 21, and we did this sample. So this example, I would say you should write down. It's going to take a little bit of time. If you've downloaded the PDF, it will help you and save some time. Okay, so here's where we're at. We have our first column here are the people that are over 21. The second column are the people that are under 21. Then we go to the row. These are the amount of people that passed. These are the amount of people failed. So if I look at this first box, what this says in the yellow is 36 people over 21 passed the test the first time. If we look at this number right here, what this says is 12 people under 21 passed the test the first time. So you could go through these other 2 boxes. Let's just go ahead and do that. So this is over 21 years old, and 4 people failed it the first time. And then this last one, 8 people under 21 failed the test. So the first thing you want to do is we're going to go out and calculate what should have happened, the expected from a normal distribution. So we're going to do these totals. So we're going to add 36 plus 12 together to give us 48. So 48 people out of our sample passed the test the first time. We're not worrying about their age. Then we're going to add 4 and 8 together to give us a total of 12 people. 12 people out of our entire sample failed the test the first time. And then if we add up this column here, 48 plus 12 is 60. That should match up, 60 people total. Now we're going to go ahead and add these 2 numbers. 36 plus 40, or 4 is 40 people we observed, got information from, were over 21. And then 8 and 12 is 20. We went out and surveyed 20 people under the age of 21. Again, if you add these 2 numbers, you get 60. This is our observed values. Now, looking down below here, we're going to make a judgment call. We see from the table there's a higher chance that amongst the over 21s. Is it purely by chance, or is there some connection between driving that test and passing it and your age? So we're going to do some hypothesis testing later on. All right, here's what you're going to do in your assignment today. We are going to go out and calculate what we call these expected values. And this is the formula that you already have written down. And what you do is you take the row total times the column total and divide it by the total people in your sample. And you should write down this entire slide. All right. So the four numbers in the yellow here are what we went out and observed. And then we went out and did these totals. So I'm going to go ahead and write down over 21, under 21, passed, failed. And what we're doing is we are calculating the expected values, what should have happened in a normal distribution. All right, so what we're going to do first is we're going to try and calculate what should have happened in this spot. People that are over 21 that passed the driving test the first time, okay? So what you do is you take the row total, so that's 48, and the column total, which is 40. We're going to multiply those two numbers together. So 48 times 40. Then we're going to divide it by how many people we surveyed? 60. And then we're going to use our calculator. So we take 48 times 40, and we're going to divide it by 60. And what we get is 32 people. So what should have happened when we went out and did our survey is 32 people should have been over 21 and passed their driver's test the first time. Okay, so I'm going to go ahead and erase this again. Now I'm going to go on to this box. How many people are under 21 and passed the driver's test? So I'm going to take my row total, 48, and my column total, 20. So 48 times 20, and then I divide it by how many people I surveyed, 60. And let's see what we get. So 48 times 20 divided by 60. And we get 16 people. So we should have gotten 16, and we got 12. All right, we have two more to do. Now we're heading down to this box. People are over 21 that failed the test the first time. So we're going to now go to our row total, which is 12, and our column total, which is 40. So 12 times 40 divided by the number of people, 60. So 12 times 40 divided by 60. And we get 8. Well, we ended up with 4. So we were a little low there. All right, and our last one. We want to figure out how many people under 21 failed the test. What should have we gotten from our sample if it was normally distributed? So we take our 12 times our 20, row total, column total, and we divide it by 60. So 12 times 20 divided by 60. And we get 4 people. We were a little higher than that. We had 8 in our sample. All right. So we are going to use these 4 numbers in a little bit, because we're going to calculate from the observed and the expected this chi-squared value. All right, and that's what's leading us to our formula. To calculate the chi-squared value, we're going to use this formula right here. Now, if you want to use the formula as it looks in one big equation, you can do so, and that's fine. This represents the sum. This represents your observed, what you got from your sample, minus what you were supposed to get, your expected, which we just calculated, and we are going to square it, and then divide it by your expected. Okay. So that just kind of talks about what the O and the E are. So we're going to set up a contingency table that looks like this. So go ahead and pause and write this down. All right, so this is your observed, what you got from your sample. So there was a group that was 36, 12, 4, and 8. Let's just go back. 36, 12, 4, and 8. Then we calculated, and we got 32, 16, 8, and 4. Those 4 numbers are going to go in your second column. Okay? All right, so now we're going to start to calculate our chi-squared value. So we're going to take O minus E, so 36 minus 32, which is 4. Then we're going to square that number, and we get 16. Then we're going to take that number and divide it by E, which is 32. So 16 divided by 32 is 1/2. And we'll do that as we go through. So 12 minus 16 is -4. Square it, we get 16. Then 16 divided by E, and we get 1. Then we take 4 minus 8, -4. Square it, we get 16. 16 divided by, our expected is 8. We get 2. Then we take 8 minus 4, which is 4. Square it is 16. I made this problem nice and easy. So usually I'm going to give these nice pretty numbers. So 16 divided by 4 is 4. All right. And then what you do is you total up the columns. These numbers right here in this last column. And you get 7.5. This is what we call the chi-squared value. We're going to use this later in another video. Now, look at this. If you like it written like this, you can do so. So that's taking the sum and writing it out like that. So you're welcome to do that if you want to. Or you can use the contingency table with the boxes.